In today's course, what I want to do is go over the process of writing a lab report. In the lab section of your Brightspace, you'll see in the announcements section, you'll see these instructions here. So I want to go over them quickly with you, but then I want to expand on this and actually show you how to write a real lab report. Because it could be the case that when you're in grad school, you have to write a lab report. Or it could also be the case that you have to read hundreds of them. So for me to do my dissertation, I must have read at least 1,000 articles. And sometimes your advisor will say, I want you to review these 50 articles by tomorrow morning and tell me which article is the most relevant to our research. Oh boy, read 50 articles. How do I do that in the course of an evening? Well, you're not necessarily reading every word of the article. What you're doing is anticipating where information will be. Because if everybody agrees to follow this format, and it's actually not this format. This is a very simplified version of what I'm going to go over today. But if you agree to follow this format and everybody writes with this format, then if I want to find the material methods section, I'll know that I should find it after the purpose and introduction. The results are always after the material methods section. So if I want to find the results and my PI or my principal investigator says, highlight the results, I'll know exactly where to go. Look right after the materials methods section and there'll be the results. It's just, what do you put in the purpose, introduction, and the material methods? What do you put in here? What information? How long should the purpose and introduction be? Now, usually, with everything, like if I give you a guitar and there's no technique to play chords, then the guitar remains a mysterious instrument. But if I teach you how to play a couple of chords and those chords are consistent over a long period of time, then if you keep applying that chord structure, slowly but surely, you start to understand how to play guitar. But if the chord structure changes every day, or if the chords in Spain are different than the chords in Israel and they're different than the chords in United Arab Emirates, then nobody's going to be able to play like a consistent guitar. So the consistency of the technique allows for there to be reliability and objectivity in that technique. Reliability is the ability to personally repeat the technique over and over, and objectivity is the ability for multiple people to perform that technique and get the same result. So I'm going to go over this very quickly, and this is all that you have to do for your lab reports. And soon, because we only have about a month and a week of school left, soon you should start doing all these lab reports, like just about once a week. The sooner you get the lab reports submitted, the sooner I can make comments and get them back to you. And if you make corrections, I'll give you better grades. So I want to start with just what's written here, and then I want to open this up and show you the real way to do it. So when you do your lab report, this week it's on heart rate. There'll be instructions, which I'll go over how to do heart rate and blood pressure. You do not need to do blood pressure this week because we don't have sphygmomanometers at home. But I would encourage you to go to CVS and maybe put your arm in one of those blood pressure cuffs and get your blood pressure and go through the lab. But the lab that you have to do this week is strictly based on heart rate. So I'll open up the lab papers. I'll show you what we do. If I need more time, I'll go through heart rate. I'll go through blood pressure, the whole thing. But let's just go with this information first. For your lab reports, you should write an introduction paragraph. It should be relatively brief for now because you don't have a huge amount of knowledge and background. But this 6 to 8 sentences, you might want to expand on that, and I'll show you why later. Any lab report or any actual article that you're going to publish, this introduction should be more, obviously, than 6 to 8 sentences. But for you guys, if you kept it to this would be fine. But I don't feel as though I'm completing my obligation to you if this is all the information that I give you, because there's a lot more to it. For you, though, you should keep your introduction relatively brief and tell me, why are you doing this lab? The reason why you're doing the heart rate lab this week is, especially if you take a look at the heart rate worksheet that I gave you, if you can do a little bit of exercise, endurance training, and you reduce your heart rate a number of beats per minute, resting heart rate a number of beats per minute, then how many heartbeats would you save over the course of your lifetime? It's on the order of 20 million heartbeats over the course of a lifetime. And that is certainly going to improve your cardiovascular health. If your heart doesn't have to beat unnecessarily, that's probably a reasonably good thing. So in this introduction, you're going to tell me, why are you doing the lab? And I'll explain how to do that. And you're going to describe the major concepts, which is like ideology and terms that you're going to do. And then at the very end, what is your hypothesis? And a hypothesis is a prediction. We predict that individuals who are more athletic or are more highly endurance trained will have a lower resting heart rate and therefore save X beats per minute, or sorry, X heartbeats over the course of their lifetime. And in the lab write-up, if you take your heart rate and you plug it into the equations and the lab information, it will give you how many heartbeats you're estimated to save. And that's kind of the beginning of the lab write-up. After the introduction always is the materials methods section. The materials always starts with the participants, and then it talks about your equipment. The methods is what you did to take this data. Everything should be written in complete sentences. Use your lab manual if you need, but don't copy it. And mention any equipment that you used and the techniques that you used. At the end of the material methods section, if I read what you wrote, I should be able to accurately replicate the methods that you used in order to complete the lab. The results section should be very, very simple. Really, for you guys, it should only be maybe a figure or a table. You're just going to take your heart rate 3 times, put it in a graph, tell me what your heart rate is, make it very simple. There is no analysis or description in the results section. It should be very clean, though. Each figure or table should be on a separate page at the back of the lab report. Very, very clean. Make sure each of your things has a title, a key, or a caption if necessary. But very stark. Your results are very stark. Then your discussion, you're going to discuss a number of different things. And I'm going to go into this pretty extensively because obviously a discussion is where the meat of the writing is and where all of your hypotheses are explained through your data. There is a good potential for writer's block right here. So to get around writer's block, what we need is a technique of writing. And if you have a technique of writing, then you just apply the technique And then what happens is a pretty well-written lab report. So what I want to do is expand on each of these things, because for the course of this course, for the purposes of this course, I think this is probably good enough. Now, if you don't write incomplete sentences, if your spelling is off, I got to grade something. So these lab reports are an opportunity for you guys to work on not only your understanding of exercise physiology, but in the next couple of years, your currency, or the way that you're going to be successful, especially if you're going to grad school, is through reading and writing. So you're going to have to get better at that skill set. So the first thing that we want to start with is an introduction. So an intro. And now an introduction is very specifically written. So what I'm going to do is I'm going to actually go through each of the sentences of the first paragraph. So this is the first paragraph, and you're going to have a number of sentences. And let's say we're talking about heart rate. Let's say we got 3 sentences here. And then we're going to have a line here. Then we're going to have another sentence. And then we're going to have a line here. We're going to have another sentence. And then we're going to have a line and one more sentence. And I'm going to try to write the first sentence for your heart rate lab with you. And I'm going to try to write your whole first paragraph with you. All right, so this first sentence is going to be background. And the next sentence is going to be background as well. And now you're going to have to kind of be smooth with how you write your background sentences, because they want to be clear and interesting for the reader. But the first 3 sentences are background. The next kind of section is going to be an impact statement or 2, but impact. The next is going to be problem. And this is how you write every single introduction. And if you watch or pay attention to articles that you're looking at, this is how they're going to also present their introduction. And the last one is a goal or a generalized goal. Whoopsies, that's supposed to be an O. Goal, a goal statement. So you have a background statement, an impact statement, a problem statement, and a goal statement. Let's start with the problem statement. Okay, the problem with exercise is if you give a survey to everyone in the United States, less than 50% of the country does any activity. Less than 50% of the country does any daily activity, which is crazy. Activity. Not many people exercise. So usually with exercise and health sciences, this can be a problem statement. Unfortunately, less than 50% of the country exercises. All right. Now, let's take a look at the impact statement. If you look at, say, cardiovascular disease or type 2 diabetes alone, it costs the country something of like $25 billion a year. It's a pretty big impact statement. Cardiovascular disease costs the country, and I'm just going to go CVD. Cardiovascular disease costs the country a lot of money. That's a big impact. If cardiovascular disease costs the United States every year $11, it's not a big impact. But $25 billion, especially if you look at some of the research that says 100% of the cardiovascular disease can be prevented through lifestyle, health, and exercise choices. This is a big problem. All right. Now, there's a huge impact. And if we can prevent this, we can save our country a huge amount of money. So what's the background here? Heart rate. Let's take a look at this. In our last lecture, we said that heart rate is an indicator of training status. If an individual is well-trained, their resting heart rate will be lower than normal. Indicates training. Now, what you could also say is training status. So heart rate is an indicator of training status. Heart rate is easily measured. Let me just go measured. So it's not very difficult to measure heart rate. And let's say one other thing. Heart rate indicates training status. To evaluate heart rate, the measurement is relatively simple. And then the last background statement should be something like, let me think about it. And then say maybe something like this. Heart rate can decrease with training. All right, so maybe this is our first three sentences. Measuring heart rate at rest and during exercise is an indicator of training status. Heart rate is easily measured by palpating the radial pulse. With exercise, heart rate can decrease by a particular percentage amount. I mean, I'm trying to riff right here, so just coming up with everything is difficult. Maybe what you say something like this is, the heart provides the body with oxygen and fuel. Even more background. The heart gives the body fuel and oxygen. Fuel and O2. And then the heart rate is an indicator of training status. And with aerobic exercise, heart rate can decrease. Now, these are three sentences that act as just background information. So if I'm a reader and my principal investigator gives me this article to read, immediately in the introduction, I'm going to know what the reasoning or what the ideological cornerstone of this paper is. If I'm looking at arterial sclerosis, this might be important. If I'm looking at cardiovascular disease, it might be important. But if I'm looking at something like type 2 diabetes, maybe this article is already not important to me. So the introduction paragraph is going to be like, the heart is part of the cardiovascular system that serves to provide fuel and oxygen to the exercising muscles. A lower heart rate indicates an improved training status. Heart rate is easily measured, and if measured appropriately, it can, or through time with exercise, heart rate can decrease and therefore save the heart valuable beats over the course of a lifetime. In the United States, most cardiovascular disease can be prevented through lifestyle, exercise, and nutrition. And cardiovascular disease costs the country $25 billion or more. Now, we already mentioned that heart rate can decrease with aerobic training here. The problem is less than 50% of the country performs activity related to exercise on a daily basis. Therefore, this article will look at the impact of reducing heart rate on heart health. What is the impact of reducing heart rate? And that's how I would write the first paragraph for this first lab write-up. Exactly. Your sentence structure might be different than mine. And again, I'm ad-libbing right here. So, I mean, I might be able to come up with more appropriate background sentences, but this is pretty good. Like, you also want to kind of, I don't know if you know what hold on, like these logistical arguments, if P, then Q, if Q, then R, therefore P and R. So you want to kind of, if P, then Q, if Q, then R, and then if, and therefore P and R, right? I don't know if you know at all what I'm talking about these, but this is like a logistical way of kind of writing an argument. If P happens, if heart rate indicates training, and if heart rate is easily measured, and if heart rate can decrease with training, then I should train to reduce my heart rate. So you kind of use these logistical arguments to put together these three things. If P, then Q, if Q, then R, therefore Q and R. Sorry, if P, then Q, if Q, then R, therefore P and R. Impact, what's the problem? What are we trying to fix? And in exercise and health sciences, because of this right here, usually your problem statement is going to be kind of defined for you. And tell us very generally what this article is going to do. This article will look at the impact of reducing heart rate through exercise training. Or this article will look at the impact of reducing heart rate on overall heart health. And how are you going to make inferences based upon overall heart health? Well, you're going to take a look at the lab write-up that I showed you, and that's going to tell you, or if you plug in your heart rate and you plug in the reduction of heart rate, it will tell you how many beats over your lifetime are you going to save. So the impact of reducing heart rate will mean that you're going to save millions of beats over the course of your lifetime, and that's what you write in the discussion. This is how all articles are written. And if I'm an editor of a magazine and I get an introduction that's not written this way, there's no way I'm publishing it. Now, if I ask DJ, where would you anticipate, if you got an article that you've never read before, where would you anticipate finding an impact statement?
In the introduction.
Right, in the introduction, immediately after the three background statements. If I said, DJ, I'd like you to take these 100 articles, I'd like you to read them by tomorrow, and I'd like you to tell me which impact statement, or which goal, rather, which overall goal most accurately matches the goal of the research that we're working on And I'd like you to narrow it down to 3 articles. I've given you 50 articles, and I want you to narrow it down to the 3 articles that have the most appropriate overall goal statement. Where would you look?
At the end of the introduction paragraph.
Absolutely. Last sentence, first paragraph. Now I don't have to read all 50 articles anymore. I have to look at the last sentence of the first paragraph, find out what the goal of the article is, and if it matches what I'm doing, okay, put that over to the left. If it doesn't match what I'm doing, move it off to the right and get rid of it. It's a way of anticipating where information is going to be. And if you can anticipate things, then I'm sure if Flips could anticipate where his wide receiver is going to be, that would certainly help him. So if you use these particular techniques, then all of a sudden your introductory paragraph is written, no problem for you. All right, so the next thing that we want to do is we want to take a look at what happens after the introduction. All right, so after the introduction, what we're going to do is we're going to take these 3 sentences here, and eventually I'm going to have to erase what's on the screen. We're going to have to take these 3 sentences, and let's actually, just for the example of this, I have actually four sentences. All right, I have this sentence at the beginning that says the heart fuels the body with oxygen and carbohydrate. A lower resting heart rate indicates training status. Heart rate is easily measured, and it can decrease with aerobic training. So there's 4 sentences. So after the introduction, and this is still in your like before the material methods, this still counts as the intro, but you're not done writing the intro. This is just the first paragraph of the intro. The second paragraph is going to take this information here, and it's going to explain what are you talking about here. So you're going to have a paragraph that has 4 or 5 sentences that talks about the heart. The heart is part of the cardiovascular system. It works with the lungs and the blood vessels to deliver carbohydrate, protein, and fat to the working muscles so that they can have fuel for muscle contractions. The heart also brings oxygen to the working muscles so that it can help break down ATP, break down carbohydrate, protein, and fat in the mitochondria to result in a greater ATP yield. So that would be the second paragraph after the introduction. The introduction is your first paragraph. And by introduction, I mean this first background stuff where you have your background, impact, problem, and goal. The next paragraph takes this information and opens it up. And likewise, the next paragraph would take this information here. Heart rate indicates training. Now, all of a sudden, you go back to all of the graphs that we talked about on Monday, and maybe you showcase 2 or 3 ways that a heart rate indicates training. With training status, heart rate drops. It drops because it allows for more time for diastolic blood to enter the heart. If there's more time for blood to enter the heart, there's more filling of the heart and such and such. So you're taking this paragraph and opening this, the third paragraph of your intro is going to take the next sentence and tell me what you know about it. The next paragraph here is going to talk about how to measure heart rate. Heart rate is easily measured using, now don't get too far into it, using palpitation methods. Usually heart rate measurements last about a minute, and they're measured in beats per minute. And that might be the entire paragraph. You're just, well, that should say BPM, but that was not good. Undo, undo, undo. That should say beats per minute. And you're just giving any information that you can, but I don't want you to repeat what you would in the material methods. And then the next paragraph, so this is the fourth paragraph, and then you have the next paragraph is here. Now, heart rate can decrease. Why? Why does heart rate decrease? Heart rate can decrease because stroke volume increases, and also some of the enzyme activity becomes more concentrated in the blood. So maybe you have like 1 or 2 sentences about why heart rate can decrease, and those details are in the 5th paragraph of your introduction. And now what you've done is you've started with the background. You've explained all of your background information. You've told me why is this important in the first place. And if there's no problem, then there's probably not going to be an impact. So these are relatively related to each other. And then you're going to tell me what is the goal of the experiment. Then open up each of these sentences with 3 to 5 sentences that you know about. And then you have the 6th paragraph, and I'll put that over here. And this is the last paragraph of the introduction. And the 6th paragraph always starts with your hypothesis. Given the information I just wrote about in these paragraphs here, we expect this. A hypothesis is an expectation. So what are you predicting is going to happen? And maybe you have 1 or 2 hypotheses. For us, we think that if you are a trained athlete, or if you are a young, healthy adult, your heart rate should be between 60 and 100 beats per minute. That's what you guys are at. Now, if you're one of the lacrosse ladies, or if you're a runner, or if you're flips, or if you're somebody else who's in pretty good shape, you could expect your heart rate to be a little bit lower, more bradycardic than tachycardic. So you could make that also that prediction. And then what you're going to do is at the very end of this paragraph, now this hypothesis statement could be A, B, C, depending upon the complication of the experiment that you're working on. At the end of the hypothesis paragraph, you're going to write a very general purpose, very specific. All right, so at the end of the first paragraph, there is a basic purpose statement. At the end, what we're going to do is look at the impact of the reduction in heart rate on overall heart health. But here, actually, that shouldn't say general at all. That should say specific. Specific purpose. And now what that's going to mean is specific. What that's going to mean is you're going to say something like this. We will look at heart rate. We will be measuring heart rate and calculating the number of heartbeats saved if one can reduce heart rate due to exercise. Heartbeats saved. I know that's not a great heart. I'm trying to draw with my finger on my stylus here. And this is really the entire introductory section. You should try to use this format all the time. And if you start paying attention to how articles are written, you'll notice that they're all written this way. So DJ, if I asked you, where would my hypothesis statements be? Where would you look? Would you have to read the article? Where would you look? All right, maybe he's not on mic, no problem. Let's go to somebody else. If you were going to take a look and find the hypothesis statement, you now no longer, Allison, where would you find it? You no longer need to read the whole article. Anybody? Bueller. Okay.
Would it be the last sentence of the introduction?
First sentence, last paragraph, hypothesis statements. Done. So if you have a principal investigator and asks you, could you find the hypothesis statement on these 100 articles? You no longer need to read the whole article. Go to the last paragraph of the introduction. It should be the very first sentences. Where is the specific goal of this article? It's at the last sentence, last paragraph, right before material methods. Where is the impact statement? Somewhere in the very beginning paragraph, most likely fourth or fifth sentence. Where are the background sentences? Bam, right in the beginning. What does the second paragraph do? It expands on the first background statement and so forth. And now all of a sudden, there's a technique. This is pretty much your entire first paragraph or your introductory work for your first lab write-up. Now, eventually, I'm going to have to clear this so I can move on to the material methods section. But does anybody have any questions? Sweet. So the next thing is your material methods. And your material methods is always going to start with the same thing. First of all, material. Who are the participants? First thing, participants. And the next one is the equipment. You're going to have to tell me everything about this. Participants. Participants and equipment. You're going to have to try to tell me everything that you can about these so that if I wanted to replicate what you're doing in my own lab, I would be able to get the very same thing. So you're going to have to tell me like the N, how many do you have? You're going to have to tell me the age. You're going to have to tell me any demographics that is important. You're going to have to give me whether or not they're, if you're doing an obesity study, how many are in the control group? How many are in the experimental group? You're going to have to give me everything that you can about the participants. How many males and females? What is their age range? If it's important, what is height, weight? What is body mass index status? Anything that you can to tell me about your subjects. You might also have to give me like your range, an age range. You might have to give me things like weight, height, anything like that. For us, we're talking about heart rate. We're looking at heart rate. So you might want to say, if you have controls, people who don't exercise, how many people are there and how many people are in the experimental group, those individuals who are exercising. So you're going to have to give me everything that you can about these individuals, possibly even how you recruited them. Where did you get them? So you're going to have to give me as much as you can so I could follow the same recruit. I have no idea. It's okay. You'll have to give me everything that you can so I could potentially get a group of participants that almost completely matches your group of participants. Otherwise, I can't really compare the articles or our data to your data. So first is participants. That's part of the material. And you just give homage to the participants. They're people, so you list them before you list equipment. And then you're going to list the equipment. And when you do so, you have to tell me everything. Everything like the model, the company that made it. If you have like a version, what version are you using? So there's iPhones that if you're using a version something or other, 15.0 or whatever, you're going to have to give me any information that you can about the equipment that'll make it so that I can buy the same piece of equipment. You might have to give me the address of the company. You might have to tell me the weight of the equipment. You'll have to tell me the size, any of those specs. You'll have to tell me if you had anything to accompany the equipment. So for instance, you can't just say that you have a treadmill, Bruce treadmill protocol. Well, what about the computer? What about the nose clips that you put on? What about the metabolic cart that you're using to analyze the data? What about the calipers that you're using to do the skin or the body composition assessment? What about the nose clips that you're using to put on the nose to make sure that they can't breathe out of their nose and everything is captured directly through the hoses that attach to the computer? Everything. What are the participants? What are the equipment? And then the material methods. And you could also write methods, could be procedures, either way, but usually I write material methods because of alliteration. It sounds pretty good. So methods is what are your procedures? What did you do exactly from step 1 to step 2? Here's going to be pretty simple. What you're going to do is you're going to rest for a couple of minutes before you take your heart rate. So number 1, you're going to allow the subject, which is probably going to be you or your mom or your dad or your roommate, Allie, rest first. Rest for about 5 minutes. Then what you're going to do is you're going to palpate the radial pulse, and you're going to have to explain how you're doing all this. Palpate the radial pulse with your hand, and I'll show you how to do that. And this is all written for you. Again, you can copy the information from your lab write-ups to do this. Don't copy it, paraphrase it. Rest, palpate, repeat. All right, and then what you're going to do is you're going to analyze. So you're going to take a look at repeat. And then what you're going to do is you're going to analyze the data using some type of charts or something like that. And then you would have to tell me what charts are you using to analyze. All right, so what procedures? And then after you're done with the material methods section, it's always what stats did you run? Now for you, you're just going to take 3 different heart rate measurements, probably average them together, average 3 values together. And you'll want to take an average of 3 values for most of the things that you're doing in our lab, 3 values together, average 3, and then I think that's probably good enough. So again, if you're trying to find what participants, the subjects, or what participants this lab experiment worked on, and see whether or not the participants match the participants that you're interested in using in your study, there's no reason to read necessarily all 23 pages of the article. You have to be able to anticipate where information is. Otherwise, reading the 1,000 articles is going to take you 6 months. It's impossible. Now, if you agree to write this way, and I agree to write this way, meaning TJ and myself, and then Christopher Bastian goes to take a look at DJ's article, and Sam also takes a look at DJ's article, you can save a huge amount of time That's what the whole point is. If everybody writes the same way, then we can all kind of anticipate each other's work very quickly, and it saves a huge amount of effort. Does anybody have any questions? Now, if you're doing stats, you're going to have to do something like, what statistical package are you using? Are you using SPSS, which is one way or one software that analyzes data? Are you using SAS, which is a completely different statistical software package? You'll have to explain how you're running the stats and what specific stats that you're using. And that gets pretty crazy, especially if you're doing like non-parametric statistics, but we don't have to get into that. For the most part, all of your statistics are going to be just averages of 3 different trial runs, and then you would graph that. Always participants, equipment, methods, which is procedures, from the beginning to the end. It has to be absolutely accurate so that I can replicate what you're doing. As accurate as possible, step by step by step, so that somebody can replicate what you're doing. That's the most important thing about the material methods. If I want to replicate what you're doing so I can do a validation study, or if I want to replicate what you're doing so that I can build on the research that you're doing, or that the research is out there, I need to make sure that the internal validity of my experiment is the same as the internal validity of your experiment. They're comparable, because if they're not comparable, then we can't compare what we're doing. So the closer you are to establishing the same participants, equipment, methods, and statistics, the more closely I'm going to be able to replicate and be accurate in terms of, I think it's 2 C's, accurate and replicate the procedures that you're doing. And then and only then are we going to be able to compare your results with my results. Does anybody have any questions about the material methods section? For you, the participants are going to be just you. Or maybe if you use your roommate, it's going to be 2 people. Give me their age. You know, tell me some information about them. Where did you recruit them? They're students at Assumption College. For the most part, their demographic is, or their age is going to be between 18 to 25. They're going to be from Massachusetts, or a freshman from somewhere, right? There's not going to be a control, because there's only you, unless you do like, you want to say heart rate for somebody aside from you, then the control could be somebody else, but they should be the same age. But for your lab write-ups, everything's going to be an N of 1, whatever your age is, where you're from, and that's pretty much it. Okay, maybe you give height, weight, but you don't really need to do that, I don't think. That's the materials methods section. Anybody have any questions on that? Okie dokie then. The next section is your results. And the results should be very, very plain. There is no analysis in results. No analysis. You only want to provide your results. So one easy way to do that is with tables and graphs. Now, don't do a table and a graph. It's a table or a graph. Now, that doesn't mean you can only use tables and only use graphs, but don't give me a table and a graph that give me the same information. It's just a waste of ink and advertisement space in whatever article you're writing for. So tables or graphs, or you can write it out in full sentences. All right, but as soon as you start writing it out in full sentences, then people have a tendency maybe to start to analyze a little bit. So I say that if you write as much as you can in your tables and graphs, then you'll avoid over analyzing in your results section. So your results section for all of these lab write-ups should pretty much just be a table, right? That says something like name, and then it says maybe something like trial 1, trial 2, trial 3, and you have a heart rate here, which is 61, 63, 65. And then maybe you say over here that the average heart rate that you're going to use is 63. This is the heart rate that you're going to use. You know, this isn't necessarily, I'm just drawing this on my computer. You're going to want to print this up and make it look nice. Now, if you do say, for instance, this is subject 1, if you do your mom or your dad and you also want to, you know, analyze their heart rate, then it would be subject 2. And you'd like take a look at your dad, and maybe he's got 70 beats per minute and 70. And so it's just very, very clear exactly what the results are, either a table or a graph. That's it. Now, the only other thing that you would include here is if you're going to have a table or a graph, you're going to have to put anything like your p-values. P equals or is less than or equal to 0.5. So you're going to have to tell me what your statistical results are, or your F statistic, or your Z statistic, or any of the stats related to these numbers are also going to be included in your results section, any stats. So remember, if you're going to do a graph or a table, there should be some type of label to it. So the table should have a label. It should have a legend if you need, and it should have a caption. A table should have a label, a legend, and any captions that you need or anything like that to explain what the table means. Legend, and any captions or anything underneath that's going to give it so I understand what you're talking about. So I think that you're probably not going to need a legend to anything, but you will need a label. A label is going to say heart rate, participant heart rate. That's probably enough. I don't think that you need a legend here, but if you had different colors or anything like that, or if you had abbreviations, you need to tell me what that is. And underneath, it would say, if there is some type of caption, like maybe it would say heart rate for, or heart HR equals heart rate, something like that, and write it out. So if you have any abbreviations or anything like that, then when I look at the label, I understand what it is that you're talking about. And then if you have a bunch of different variables, you would want to make the results very uniform. So use either tables all the way down, or graphs all the way down, or sentences all the way down. I just want to try to make this as easy to understand as possible. But again, no analysis, only the raw information that you collected. Because all of the analysis you got to save for your discussion. Anybody have any questions here? Okay, so I'm going to undo all of this, and then we're going to go to the discussion. And the discussion is going to be very similar. It's not similar, it's just as, I guess, detailed as your introduction. It's not going to have the same information, otherwise it would be the same section, and you don't need that. But your discussion is going to have a couple of sections. There's going to be a first paragraph. Let's try to do like this. Paragraph 1. Paragraph 2. Well, let's erase this. Clear drawings. Oh, darn it. Redo. Dang it. All right, so discussion. I just want to make it so I have easier time drawing. discussion section. So let's go like this. We'll have a bunch of different sections. All right, and this will be section 1 of the discussion, section 2 of the discussion, section 3, section 4, and this is just paragraphs. 5, 6, and we probably don't need the 7 and 8, but let's just put it there in case we do. All right, the first paragraph of the discussion is always a very, very shortened version of the results. Very short summary of the results. And that could be 1 or 2 sentences long, really. For us, it's going to be something like, during this experiment, we palpated the heart rate of, that's actually even too much. You would just say the heart rate of the subject was well within healthy heart rate values between 60 and 100. In this case, the heart rate was 70 beats per minute. Very short summary of only the most important findings. Now, there could be many other findings, but right now we're going to do only the most important. Now, it could mean that that's 4 or 5 for one article. It could mean for this article, it's only 1 sentence that really showcases the most important findings. So again, if the results section is too long or too difficult to read, and my principal investigator says, what's the most important thing that they found? What you would do is look at the very first sentence of the discussion, and it should be there. The next paragraph of the discussion is what went wrong? What could you have done that maybe compromised the internal validity of your experiment? What went wrong? So for heart rate, might not be really too much. Maybe because it's the first time, you don't know how to palpate correctly. Maybe the individual has a very faint heartbeat and it was hard for you to count, so you might have missed a few beats. All right, maybe maybe you just don't know how to feel for the heart rate. So what you're going to do is what went wrong, and what that is an indicator of any internal validity problems that your article might have. So what is internal validity? Internal validity refers to how valid or how accurate or how much faith do we have that the experiment that you did was correctly performed. Now, what you would say is, for here, maybe in this article, you would say something like, if this is your first time, what went wrong? This is my first time performing a heart rate experiment and palpating the radial heart rate. In this case, palpating the radial heart rate was very difficult because the individual is a highly trained athlete and their heart rate is very slow or lower than normal, and it's not beating too hard. So I could have missed 1 or 2 heartbeats here. What you're doing with this paragraph is you're making an admission of everything that could possibly have gone wrong. Maybe they didn't wait for 5 minutes before they did the heart rate. Maybe prior to looking at the heart rate, you were working on an exam and that stressed you out, which maybe made your heart rate higher than normal. So with this paragraph, you got to make an admission of what you did wrong. You're admitting to any potential internal validity, the validity of the internal, the inside, or the inner workings of the experiment. Did anything that I did in terms of technique result in any inconsistencies or any problems with this data? Then the third paragraph, what you do is you compare your results to the norm. Compare to well-established articles, or compare your data to a gold standard. Now, sometimes a gold standard is going to be a graph. And for you, it might even be just of value, because you already know that a resting heart rate between 60 and 100 is pretty reasonable. And most likely, if an individual is highly trained, then they're going to have a resting heart rate that's closer to about 60. And then you take a look at the data that you got. And Flips is a pretty well-trained athlete. And when I take a look at the summary, the very short summary, Flips' average heart rate was 63, hypothetically. 63 beats per minute. So when I take a look at that and I compare it to the gold standard for somebody who is an athlete at his age, it should be between 60 and 100. And I look over here and his is perfectly where I expected it. So even though things could have gone wrong with the way that I palpated or the numbers that I counted because I couldn't feel all of them, even though there could have been problems with the validity of the way that I ran the experiment, when I compare what I got to other articles or to other gold standards, the results that I have fit right in the range of the data that either those other articles or the gold standard has. So I'm expecting it to be closer to 60. I look at Flips's heart rate and it's 63 beats per minute. Apparently stuff didn't go wrong. So I tell you what I got, I make an admission of the problems that I had, and then I compare it and say, well, it seems as though, although there could be these potential internal validity issues, it seems as though they're not really kind of working themselves into our data, because when I compare Flips's information to the gold standard, we're right on the money. The next paragraph is going to say, and remarkable are these findings. Remarkable findings. So this is what's going to set your article apart from everybody else now. This is where you're going to add to the research, or that you're going to be able to make some type of inferences based on this information. And that's where you guys are going to tell me how many heartbeats are you going to save if you can reduce your heart rate through exercise according to the lab instructions that you have. And this is going to be a pretty big impact statement, because the number of heartbeats that you'll save over the course of your lifetime is going to be like in the 30 million mark. And that's pretty remarkable. Now what you do is, given the remarkable things that you have, what you want to do is you're going to want to continue this research into the future. And we have 6, 7, and 8 here. Let's go like this. Let's erase this. And it could be the case that you have remarkable here and remarkable here. It depends on how many remarkable things do you have. So this could be remarkable here. This could be something also that your group has discovered that other people in these gold standards haven't found. And because of this, because of 4, 5, and 6, it's going to drive you to do future research And it's going to make it so that your next article is already prepared and already written for you to get your grant. And then the last paragraph is your acknowledgements. Acknowledge. I'm not going to do the whole thing. Acknowledge. Done. Everybody gets that. And what you're doing is you're building up a direction or a story of relevancy here. This is what I found most importantly, but admittedly, some of the stuff that I did could have gone wrong. And you want to think of everything that you could have done wrong. It could be the case that you worked with your dad this week, and your dad could be on Ventolin inhaler, an albuterol, or he could be using Primatene Mist, which is an ephedrine inhaler, which ephedrine, which is a catecholamine, is going to increase sympathetic nervous system activity, which is going to increase heart rate, increase breathing rate, increase vasodilation. So if that's the case, and he had a Primatene Mist or an albuterol inhaler 4 hours ago, well, that might be something that changes the internal validity. Or if before the game, you know, an athlete is taking RIP fuel or caffeine or something, those could also be issues. So what went wrong could be nutrition related, rest related. It could be the fact that they come into the lab and they have a sweatshirt on, and I have to palpate your radial pulse or pull your sweatshirt up to do your blood pressure, but the sweatshirt at the top of the arm is going to crimp the bicep a little bit and make it so that the blood can't flow through that particular, those vessels easy. So that could also change the validity of the experiment. So everything that could have gone wrong, and then compare it to stuff that has already gone right. So even though this stuff could have gone wrong, I'm getting the same results that other people did. And this right here is called external validity. Am I getting results that are comparable to the outside population? External validity. Anyway, it's an N. External validity. And then tell me what your article did above and beyond all the gold standards here, here, and here. And what does that mean for future research? What are you going to do based on the information that you have now? Well, in the future, what we do is provide the football team at Assumption College an aerobic training regimen that is designed to, or maybe, and not the football players, maybe what you do is you provide information to the students at Assumption College regarding the impact that you can have on resting heart rate and therefore the number of beats per minute with just a very short aerobic training regimen. This is the training regimen. We're expecting to get a group of controls and healthy young subjects and see whether or not this training regimen that we suggest based on all of this research is going to be functional. And that article will be started, or our group will be applying for a grant, shortly. I'd like to acknowledge Flips and Sam and the two ladies in the penitentiary for their hard work and such. And that's pretty much how you do a lab write-up. I know it's complicated in some instances, but it's actually not. It's just like writing a song. If you have no technique, then it's really difficult to work on no technique. But if you have a technique and you start to notice the technique that other people use that's similar to this technique, then it starts to get a little bit easier and easier. Okay, does anybody have any questions about any of that? Okie dokie. So what I'm going to do is I'm going to get rid of this. I'm going to stop sharing. I'm going to stop recording.